Hi, this is Mr. Woodbury from College of the Sequoias. This video is for my Math 21 students. We're in section 13.1, and now we're going to talk about the non-parametric alternative to ANOVA, which is called the Kruskal Wallis test. All the data in this video can be found in the Woodbury Math 21 StatCrunch group under section 13.1. The Kruskal Wallis test is the name of the alternative test to ANOVA. A quick recap, the conditions for ANOVA are two. First, the largest sample standard deviation can be no more than double the smallest sample standard deviation. And second, each sample must come from a population that's normally distributed. We can check that using a QQ plot. If the conditions are not all satisfied, we can then turn to this non-parametric test known as the Kruskal Wallis test. By the way, in the two ANOVA examples I did in the ANOVA video, I checked that the samples were normally distributed first. However, I'm going to begin to check the standard deviation condition first, because if one of these fails, my experience tells me that it's going to be the one dealing with standard deviations rather than the one dealing with data that are normally distributed. So I'm going to check that one first from here on in. The changes for this test. This test is now about the equality of three or more population medians. So that means that the null hypothesis will be M1 equals M2 equals M3, where M stands again for the population median. In H1, rather than at least one mean is different than the others, now we'll say that at least one median is different than the others. For step 3, the name of this test is Kruskal Wallis test. And the calculations in step 4 are done by using stat, nonparametrics, Kruskal Wallis. Pick the columns that contain the data, click compute, and you'll have your p-value. Finally, in step 5, the conclusion should refer to medians, not means. In other words, we'll say there is or is not sufficient evidence to conclude that at least one median is different than the others. Let's try an example. The data in the table represent the number of corn plants in randomly sampled rows for various types of plot. An agricultural researcher wants to know whether the mean number of plants for each plot type are equal. So we have 6 rows for sludge plot, 6 for spring disc, and 6 for no-till. At the 0.05 level of significance, test the claim that the mean number of corn plants is the same for all 3 plot types. So we're talking about 3 means being equal or the same, and we have 3 sets of numerical data independent samples. This is an ANOVA test, or at least it seems like an ANOVA test. A quick note here, the sample size is 6, so if we do get to the QQ plots, the critical value for a sample size of 6 is 0.888. One more thing to make note of, I'm going to let population 1 be sludge plot, population 2 spring disc, and population 3 will be the rows with no-till. Let's start to write up the test. The null hypothesis, if this is ANOVA, is mu1 equals mu2 equals mu3. H sub 1 is that at least one mean is different than the others. The level of significance is 0.05, and again, this appears to be ANOVA. Okay, let's go to StatCrunch where we can check the conditions and then calculate the test statistic and p-value if those conditions are met. If they're not met, we're going to switch out to the Kruskal Wallis test. The data are in the columns labeled sludge, spring, and no-till. First, we'll check to see that each sample comes from a population that's normally distributed. Press graph, QQ plot, select those 3 columns, sludge, spring, and no-till. Add the correlation statistic. Since each sample was of size 6, the critical value is 0.888. We want to make sure that the correlation statistic is greater than 0.888 for each sample. Press compute. For the first, we have 0.962. For the second, 0.891. And the third, 0.974. They're all greater than 0.888, including the second one barely, but it's still normally distributed. So that part of the condition is met. Let's check the other condition in the ANOVA test. Stat, ANOVA, one way. select the columns sludge, spring, no-till, compute. The smallest standard deviation is approximately 1.1 for spring. If we double that, we get 2.2, and the other two standard deviations are larger than that. That means the conditions fail and we cannot perform the ANOVA test. So we'll throw that one out and we'll perform the nonparametric alternative, Kruskal Wallis. Press Stat, Nonparametrics, Kruskal Wallis. Select the three columns, sludge, spring, no-till, and compute. The p-value for this test is 0.009. Okay, we found the conditions were not satisfied, so we're going to rewrite what we have so far. We need to change all of the mu's in H sub 0 to be m's. We're going to have to change where it says mean in H sub 1 to median, and we're going to have to change the name of the test. Let's go ahead and get started with that. The null hypothesis, M1 equals M2 equals M3, and H1, at least one median, is different than the others. So it's important to note in this first step that we've made a shift from means to medians. The level of significance still 0.05, and the test is Kruskal Wallis. The calculations, we found our p-value was equal to 0.009. That is lower than alpha, so we're going to reject the null hypothesis. And that means that there is sufficient evidence to prove that H1 is true. In other words, that at least one median is different than the other. So in this problem, because we rejected the null hypothesis, we were able to prove that there was enough evidence to show that at least one of these medians is different than the others. Now again, this test doesn't tell us which median is different, just that they're not all the same.